Now, I promise I'm really going to do proposition 4 again. And I think you guys all really need to study this and think about it, okay? And by the way, you can talk to each other, show each other videos, and ask questions. I know some of people are really willing to help. In this proposition, we're going to use something in our bucket, okay? And that is, something cannot both be equal and not equal at the same time. If somebody says that, we say no, because our intellect sees that it's false, and we're not going to put up with that, okay? So, here's proposition 4. If there be two triangles such that two sides are equal to two sides respectively, this side equal to this side and this side equal to this side, and the angle, that's what that little dash means, that they're equal, the angle those two sides contain are also equal, the angles are also equal, it must be the case that the base of the other triangle is equal to the base of the one, the angles that remain are equal, and the area of the triangle equal. And we're going to prove that they're equal in area by coincidence. Remember, two things which coincide are equal? That's the whole thing in proposition 4. We're going to show that they coincide perfectly. So let's do this. We know we can take something up and put it on something else. To be precise, we're only going to put two things exactly on each other. This point of this triangle on this point of this triangle. And this blue line on top of this blue line. Therefore, the 2 points will fall on top of each other, right? And most of you say, obviously, in your videos you sent to me. But my intellect says, prove it. And all right, I'll prove it right now. We know that we line the blue line up, right? So the lines coincide. The question is, do the points coincide? I say yes. Mr. Smarty Pants says no. Okay, Mr. Smarty Pants, says my intellect. If they didn't line up, it would either fall, the line would necessarily, the point would be either here or here. That is to say, the line would fall short or fall further, right? Right, there's only 3 options, because the lines are lined up on each other. It doesn't fall over here or fall over here because we lined them up on top of each other. The only question that remains for this line, does the point line up perfectly with the other point? So you say it must either then go longer or shorter fall. There's only 3 options. Let's examine if it goes longer, that they don't line up, that this point comes way out over here, say. Like way out over here. And then you would say, well gosh, this line is greater than this line. The whole is greater than the part, we know that. So this one is greater. One thing greater than another is unequal to it. But it was given that the 2 lines are equal. Now, I say, well, that hurts my imagination. I know, but we're doing a reductio ad absurdum, remember? Hey, Mr. Smarty Pants, you say they're unequal? Okay, let me grant that they're unequal. It falls either longer or shorter. If it falls longer, then Mr. Smarty Pants is like this, yeah. And he says, I don't care if it looks bad in my imagination, I still, okay, Mr. Smarty Pants, now we've got a problem. That this line is both equal to this line and unequal at the same time in the same respect. Mr. Smarty Pants says, well, I'm not going to say that it's longer, then that's really dumb. I don't want to be embarrassed in front of my friends. But what if it fell short, huh? What if it didn't go so far, like it only fell right there? Okay, Mr. Smarty Pants. Let's say that when you put these on perfectly, this point on this line on this line, let's say that it does fall short. Great! Now this line would be greater than this line because the whole is greater than the part. Great, Mr. Smarty Pants says. Hey, Mr. Smarty Pants, if one thing's greater than the other, they're unequal, right? Right, of course they're unequal. But Mr. Smarty Pants, it was given that they're equal. Oh, yeah, you're right about that. So I can't say that it falls short. And you can't say that it falls longer, right? Right. So what do you have to say, Mr. Smarty Pants? That point falls right on top of that point. That's right. That's what the intellect sees that. There's no way of denying it. You might be able to imagine something, but you can't deny it with the intellect. Thanks be to God that the intellect asked those questions and the imagination obeyed the intellect, even though it was difficult for the imagination. Hey, how could it fall? That's weird. Just obey the intellect because it's doing a reductio ad absurdum. Great. That's enough for now. We'll finish the prop in the next part. Thank you. Bye.